In this video, we'll learn to write conversion factors and we'll learn how to work with significant figures in conversion factors. The maximum amount of mercury allowed in tuna is zero point 0.5 parts per million. What does this mean? We'll explore that further also in this video. Equalities use two different units to describe the same measured amount. They're written for relationships between units of the metric system, US units, or between metric and US units. For example, 1 meter is 1,000 millimeters. 1 pound is 16 ounces. 2.20 pounds is a kilogram. Anytime you have an equality, you can use that equality as a conversion factor. Remember, as we talked about previously, anytime you divide a number by itself, you get 1. And if you divide a number by a number that it's equal to, then you also get 1. We can use this property to express numbers in different units. For example, we know that 60 minutes is an hour, and 1 hour is equal to 60 minutes. So if we divide 60 minutes by 1 hour, we get 1. If we divide 1 hour by 60 minutes, we also get 1. So if we multiply a quantity by 60 minutes over an hour, we're multiplying it by essentially 1. We haven't changed the essence of that number. The same is true, for example, for 100 centimeters is equal to a meter, and a meter is 100 centimeters. When we divide 100 centimeters by 1 meter, that's the same as dividing a number by itself. So we get 1. If we multiply a number by 100 centimeters divided by 1 meter, we haven't changed the essence of that number. We do, however, need to keep in mind the number of significant figures in our conversion factors. If we're converting between two metric units or between two US system units, the numbers are obtained by definition and are therefore exact. If, however, we're converting between metric and US units, one of those will contain a number obtained by measurement, and that measured number counts toward the number of significant figures. We do have one exception, and that is 1 inch is defined as 2.54 centimeters. This has been defined by definition and is therefore an exact relationship and doesn't limit our number of significant figures. This is an exception, and it should be memorized so that you'll know that it doesn't limit your significant figures. Here's a chart of common equalities that can be used as conversion factors. We know that, for example, 1 kilometer is 1,000 meters, and 1 centimeter is 10 millimeters. And these do not limit our number of significant figures because we're converting within the same system. 1 foot is 12 inches. That's also a defined quantity. 1 yard is 3 feet. 1 mile is 5,280 feet. We get these numbers by definition, and therefore they do not limit our number of significant figures. But when we convert between metric and US units, we usually do have a limit to the number of significant figures, except we see that 2.54 centimeters is 1 inch. That's an exact number by definition and doesn't limit our significant figures. But 39.4 inches is 1 meter. The 39.4 has 3 significant figures. That would limit our significant figures to 3 if we use that number. So you may want to look up a more precise definition of the conversion factor that you want. 15 milliliters is 1 tablespoon. 1 kilogram is 2.20 pounds. That measured number, the measured one, is going to limit your number of significant figures. Remember that when we have a conversion factor, in order to use an equality as a conversion factor, we're going to express it as a fraction. For example, 1 meter is 100 centimeters. We could write that as 100 centimeters divided by 1 meter. That's equal to 1. Or 1 meter divided by 100 centimeters. It's equal to 1, and therefore we can use it as a conversion factor. The number that we decide to put in the numerator or the denominator is going to be determined by the number we're converting from, the units of the number we're converting from, and the units we want to convert to. We'll see some examples of that later on. In this case, we're converting between metric units, and neither of these values limits the number of significant figures. On the other hand, when we're converting from metric to US or vice versa, we have, for example, here 1 kilogram is equal to 2.20 pounds. The measured value will limit our number of significant figures to the number of significant figures in that measured value. So 2.20 pounds is our measured value here, and that would limit us to 3 significant figures if we use that value. Sometimes we may find an equality stated within a problem that may be unique to that problem, and we can use that equality then as a conversion factor. It's important to recognize that an equality can always be used as a conversion factor depending on the specific case. For example, if we have a car traveling at 85 kilometers per hour, we can use that 85 kilometers per 1 hour as a conversion factor. Or if we have the price of onions being $1.24 per pound, we can use the $1.24 per pound as a conversion factor. This type of case-specific relationship will often be used for dosage problems. If we have, for example, 250 milligrams of a drug like Keflex per capsule, we can use that 250 milligrams per capsule as a conversion factor for our problem. In this case, we see that the 250 milligrams is actually a measured value and not a defined value as we see in our metric prefix conversions. Since the 250 milligrams is a measured value, it's going to have 2 significant figures and limit us to 2 significant figures in our answer. The 1 capsule is an exact number, and that 1 wouldn't limit us to 1 significant figure, but we would be limited to 2 significant figures from the 250 milligrams per capsule. We'll often see percentages expressed in problems, and we'll need to know how to mathematically handle those percentages. For example, if a person is 18% body fat by mass, we can assume that we have 100 kilograms of total body mass, and we would have 18 kilograms of body fat per that 100 kilograms of body mass. So anytime that you have a percentage, assume that you have 100 total parts and put your percentage as a part of that whole. Additionally, in problems, we often see numbers expressed as parts per million or parts per billion. Parts per million means 1 per 10 to the 6th, and parts per billion means 1 per 10 to the 9th. A more common way to express parts per million is milligrams per kilogram, and parts per billion is micrograms per kilogram. Let's express 1.9% as a conversion factor. 1.9% means 1.9 out of 100. So if we had 100 grams, let's say, of salmon, we would have 1.9 grams of omega-3 fatty acids, according to this percentage. Now let's examine that a little further. Notice that the 1.9 is a measured value, and that's going to limit our number of significant figures. So for a problem like this, we would have 1.9 grams out of 100 grams total, and the 1.9 would limit our significant figures to 2. Let's see how we could use conversion factors to express or convert each of the following entities: meters and centimeters. Remember that 100 centimeters is 1 meter. So we could use that as a conversion factor. We could either put 100 centimeters in the numerator and 1 meter in the denominator, or 1 meter in the numerator and 100 centimeters in the denominator. Since these are defined quantities and we're converting within the same system of units, we wouldn't be limited by the number of significant figures. If we had a piece of jewelry that was 18% gold, then if we needed to use that in a calculation, we could assume that we had 18 grams of gold for every 100 grams of the jewelry. So we'd see here that the 18% is a measured value, and therefore we'd be limited to two significant figures from that number 18. Next, we have an example where 1 gallon of gas is equal to $3.40. $3.40 is a measured value. So we could say $3.40 per 1 gallon of gas. The $3.40 would limit us to the number of significant figures. This is a bit ambiguous. This is an ambiguous number, but we can assume that we had two significant figures. Next, we have a problem where we see that 1 gallon of gas is $3.40. If we were using this in a problem, we could express our conversion factor as $3.40 per 1 gallon of gas. We could also say 1 gallon is equal to $3.40. Notice that the $3.40 is a measured quantity. Since the $3.40 is a measured quantity, it will limit us to three significant figures.